The first one would be press pellet sample preparation, because it would provide the best performance for minor and trace elements. When we talk about trace elements, it's less than 0.1% or less than 1000 ppm, or also for the analysis of similar materials. So the preparation is done first by crushing, grinding, and then mixing with a binder if necessary. Second step is to press the sample in a die. Usually 20-ton pressure is sufficient. And finally, we get a nice pellet with a flat surface that is easy to present to the XRS spectrometer. So it's very simple technique to prepare the sample, and that's one of the advantages. So this straightforward sample preparation with grinding and pressing steps, it can be also adapted to small quantities if we don't have enough material. There is no or minimal sample dilution. Maybe the dilution is brought by the binder, but generally we will never use more than 10% binder. In the cases the powder does not agglomerate well, which means we get the highest signal intensities on the trace and the minor elements. The drawback is that the calibration generally can only be done for one type of sample species, like for example, one calibration for cement, one calibration for slags, another one for limestone. But sometimes we can mix together more different minerals and make calibration, for example, for soils and sediments or for rocks. In these cases, we can cover quite a number of elements, as mentioned here, up to 35 elements in some cases. The second step, or the second way of preparation, is the fused bead sample preparation. In this case, we are going to turn our mineral sample into a glass disc through fusion. In a fusion machine, we see here typical gas fusion machines, but there are also existing electrical fusion machines that are more and more used right now. And by doing this transformation from a mineral into glass, we are going to get some advantages in terms of homogeneity of the matrix, in terms of no problems with the grain size, so no grain size effects. This techniques also removes any mineralogical effects, and in the end it improves the accuracy of analysis, mostly for the majors and minor elements. So typically when we are above 10%, the effect is really quite big, and less so when we are below 10%, from 1 to 10%. One of the disadvantages, of course, is that we are going to dilute the sample. Typical ratio is one part sample and 11 part flux. The flux being a mixture of lithium tetraborate and lithium metaborate, typically. And this dilution means that the limits of detection for trace elements will not be as good as we get when we just press the sample as previously presented.